So here's the physicsclassroom.com optics bench, interactive optics bench. You click here to go full screen, and here's the app that opens. And it opens in the lens mode. Okay, here you can move the object around, you can change the height, you can change the focal length. But we want to study not lenses. That's the next section. We want to switch here from lenses to mirrors. So here's a concave mirror, and here's an object moving and the image that's formed. So before we get started here, let me turn off all these rays. Here's the principal rays 1, 2, and 3. That's funny. Oh yeah, okay, it shows where the object. Here's the object, okay, and I'm going to turn on this ray here. Here is a ray that leaves the object and it comes parallel to the optical axis. Here's the optical axis. The optical axis is a line that goes through the center of the mirror and goes through the center of curvature and the focal length. So principal ray number 1 is a ray that leaves the object parallel to that optical axis. It bounces off the mirror, and by definition it goes through the focal length. So here, so somewhere along this line is where the image is. This focal length is half the radius of curvature. That's the radius of curvature there, which is 2 times the focal length. Let me turn off that ray, turn on this ray. This ray is the inverse operation. It goes through the focal length and it comes out parallel. Okay, it is though a ray coming in here parallel goes through the focal length. Well, that was what ray 1 was. Parallel to the opposite goes through the focal point. Turn that off. Ray 2 goes through the focal point, strikes the mirror, and comes out parallel. Turn off that one, and here is ray 3. Ray 3 goes from the object directly to the center of the mirror on the principal axis, and by symmetry those two angles are the same, so that ray goes at the same angle coming out that it had coming in. This angle here is equal to this angle here. Turn on all 3 of those rays, and where they converge is where the image is. Okay, I only need 2 of those. I could either use those 2 or those 2 or those 2. All 3 just gives you confirmation. So that's kind of the tutorial aspects of this thing. If I change the focal length, I change the object, the image location. Okay. But the more instructive thing, and what I encourage you to do, is to set the focal length, okay, and watch what happens as I come in from an object as far away as I can. Now, in this app, I can't get very far away, okay? But here, as I get closer and closer to the mirror, okay, you'll watch how this this image moves, okay? First of all, let's characterize this image. The 3 characteristics we want are upright or inverted, magnification, and real or virtual. This object in this configuration is inverted. Right now it has a magnification of less than 1. Okay, it's smaller than this, and it's a real image because all the ray projections actually go through that point. Okay, I could project it onto a screen. If I held a screen there, I could make a projector out of this. Watch what happens as I bring the object in closer and closer. The image gets bigger, gets bigger, it gets bigger, it gets bigger. Look what happens right at twice the focal length. The 2 are in the same location. The magnification is 1. As I keep going in closer and closer, the image gets bigger and bigger and bigger, and so on. Okay. Now the image is way off to infinity here, but look what happens when I go on this side. When I get inside the focal length, the image flips side and it goes on the other side. Now it's always bigger than the object, okay? And it's always a virtual image because the rays bounce off the mirror, go this way, and this way. They don't actually go through the location where the image is. Their projection does. So that we call a virtual image. Characterization, it's upright. It's not inverted anymore. It's the same upright as the object is. Its magnification is always going to be greater than 1 once it's inside here, and it is a virtual image. So I encourage you to play with that, with this app, looking at how that variation goes from one side to another. Have fun with this.